Hello and welcome to Nikolai's genetics lessons, and today we are going to talk about ratios and proportions. Why it is important? It is important for your laboratory class. Basically, this is most important thing to know in order to prepare stock solutions. So I will start with very easy examples, and later on I will show you more complex examples, but let's do everything in turn. So today's problem is mark yes or no for each pair of ratios below based on whether they are proportional. The first two are done for you. So let's analyze what we see here. So first of all, what is the definition of the proportion and ratios? So we told that we have here two pair of ratios that we have to compare and decide whether this ratio is proportional or not. So basically here is one ratio, here is another ratio, and together we say that this is proportion. So proportion is relationship between two ratios, and in some cases two ratios relationship can be proportional, like in this example. So in this ratio we have smaller number and larger number, and in this ratio we also have smaller number and larger number. And if this smaller number, for example, twice smaller than this, and this bigger number is twice smaller than this, or we also can say that this number is twice bigger than this, and this number is twice bigger than this, then this relationship is proportional. But let's take this example, one ratio, another ratio, and this one and this two, like you see 2 is twice bigger than 1, but if we consider the biggest number, we would see that here, in order for these two ratios to be proportional, we should have 8 instead of 7. So this number also have to be twice bigger than this, so these two ratios would be proportional. So we say that there is no proportion here. So let's now consider this proportion. So what we see that smaller number in this ratio is twice smaller than this smaller number in this ratio, and this 3 is twice smaller than this 6. So we can say that these two ratios are proportional. Now let's consider this proportion. So 8 is twice bigger than 4, but here we should have 10 in order for these two ratios to be proportional, but we have 12. So we can say that these two ratios are not proportional. So 3 to 4, and here we have 7 to 12. And 4 3 times smaller than 12, but 3 is not 3 times smaller than 7, so we can say that this is not proportional. 5 and 6, 10 and 12 are proportional. And next two ratios, 7 to 10 and 21 to 30. Again, for example, this is smallest number in each ratio, and this is going to be biggest number in two ratios. And we see that the smaller number in one ratio is 3 times bigger than another ratio. We also should expect that another number also would be 3 times bigger. And we see that here this pair of ratios are proportional. So 3 times bigger smaller number and larger number. So this is proportional. 10 to 2 and 6 to 1. And in order for these two ratios to be proportional, if we consider, for example, this ratio, we should have here 2 and 12. Or if we consider this ratio, we should have here 5 instead of 6. So this is not proportional. And the last one, 9 to 3 and 9 to 27, is proportional. And one more slide with more word examples. Answer yes or no to the questions below based on whether the prices are directly proportional. And the first question, 1 can of juice for $2. So we have 1 and 2 here, and 4 cans for $6. So 4 for $6. In order for these two ratios to be proportional, as you see, we have 1 and 4. So here this number also have to be 4 times bigger than this number. So we should have 8 here. But we have 6, and this tells us that seller offered discount based on the quantity. So these two ratios are not proportional. So next, 5 liters of paint for $12 and 10 liters for 24. So we see that here 10 is twice bigger than 5, and 24 also twice bigger than 12. So these two ratios are proportional. Next, 75 grams of the chocolate for $1.50 and 150 grams of the chocolate for $3. So again, as you see, 75 and 150, so a smaller number in each ratio. When we compare two ratios, we see that this number is twice bigger than this. And we also see that this number is twice bigger than this. So these two ratios are proportional. Next, 3 pairs of socks for $3 and 10 pairs for $8. Now let's compare these two ratios. And we see that 10 is more than 3 times bigger than 3. But 8 is not 3 times bigger than 3. It's less than 3 times bigger than 3. So we do not see here that these two ratios are proportional. And the last word problem, 20 pencils for $2 and 50 pencils for $4. And we see that in order for these two ratios to be proportional, 50 pencils price have to be $5. So basically $1 for 10 pencils. 20 for 2, then 50 have to be for $5. So we do not see proportion here. So these two ratios are not proportional. I hope this information would help you in your lab, and in next video I would offer you more complex problems, and you would be easily able to convert different numbers and quantities. Sometimes you would have some chemical which is going to be limited, so you have to change the whole formula, and you would be able to do it very easily. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. Share this video with your classmates, and see you in the next video. Goodbye.